Hey everyone, we're actually going to be finishing our chapter here on the chi-square test distribution with the final kind of chi-square test that is going to be relevant to the AP exam. So let's get started taking a look at this. This is the chi-square test for independence. So this is a really good question for us. Is there an association between gender and preference for English or math class? Below is a data from a random sample of senior students, and the question, do we have convincing evidence that gender and favorite class are associated? Now, it's probably a good idea if we review for ourselves what it means for two events to be independent. Pretty classically, we know that independent means that knowing that one event occurs or has occurred doesn't change the probability that another event occurs. For this example, it's going to mean that if I know somebody is a male student, that's not going to change the probability that their favorite class is English or their favorite class is math. We saw in our chapter 5 that things are not quite as we might think they are. Independence in the context of statistics is a purely mathematical thing. It has nothing to do with, well, I think I should be able to like whatever I want. That's not independence as far as statistics goes. And a word that's going to be handy for us in this whole section is also going to be the word associated. So if two events are not independent, then they are associated. We have this sample, and the sample, here's our observed values. 43 of the females preferred English, 22 of them preferred math. 21 of the boys, the males, preferred English, and 28 preferred math. So we're going to fill in our expected table with this. As always, you should start with the totals. Actually, I forgot. We're not going to do that today. We're actually going to use our calculator to help us here. So let's get our calculator out. And in our calculator, we're going to go to the matrix option. So that is second, and then matrix is x to the negative 1 power. So here's our matrix, and the first trick here is that you're not going to go to names. You're going to go to edit, push enter. So now you're editing matrix A. Now we don't want the matrix that has all of the totals, all the marginal totals. So the data is only on a 2 by 2 matrix. So push enter to go from field to field. And now we're just going to enter in all of our data. Now that we have our data filled in for us, we are going to go back to the home screen. And we're going to push stat, go to test, and don't get too excited yet, but we're going to go to the chi-square test. There we go. The chi-square test is letter C on my calculator. I'm going to push enter, and you're going to notice two things. Observed, that's matrix A. Expected is matrix B. And then we're going to a color and a calculate. Now you're not going to fuss around with expected. Expected is not asking you where is the expected matrix. Expected is asking you where do you want the calculator to put the expected matrix, because once we're finished with this test, it's going to calculate the expected matrix for us. It just needs a place to store that expected matrix. So we're going to push calculate now. And we're going to get all sorts of things which are interesting to us. They'll be much more interesting to us later, including the chi-square test statistic and the p-value and the degree of freedom, which is pretty much everything you're going to need to know here. But again, we'll get to all of that later. Right now, we want to find the expected matrix. So now we're going to go to second matrix menu again, and we're going to go to edit. And now we're going to edit matrix B, and that's going to give us a nice look at the expected matrix. So that's the quick way on your calculator of finding all the expected values. Of course, you can always be asked about finding the expected value for a particular cell in the matrix. So you still need to know the formula about how to calculate expected values. But in some cases, it's best to do this quickly. So here's our expected values. Now that we have our expected matrix finished, things get a lot easier. I've already shown you a lot of the things that will make this easier. So question 3 is, do the data provide significant evidence that there is an association between gender preference and math class? Now remember, you need to memorize this phrase because this phrase says, do the 4-step plan. Okay? So let's do the 4-step plan. Our null hypothesis is there is no association between gender and favorite class. And remember that no association means that gender and favorite class are independent. Alternatively, there is an association between gender and favorite class, which means, of course, that gender and favorite class are dependent. Now, the name of the procedure is a chi-square test for independence. Sometimes that's written as a chi-square test for association. They are the same test because association and independence are, opposites of the same concept. We have the same two conditions, random and large sample. Remember that the question said a random sample of senior students, so we'll quote that into our 4-step plan. And then for large counts, our large sample, we have all expected counts were greater than or equal to 5. See table. And of course, in your work, make sure you reproduce a table of expected values. Now, this is the exact same specific formula for the chi-square test statistic. It's the sum of all the observed minus expected squares divided by the expected. For the work, you want to make sure that you show the calculation of at least 3 different expected cell counts, make sure that you show the work for at least 3 terms. But since there are only 4 different terms we're going to have to do, we'll just show all of them. Now, if you remember from earlier, we actually were able to see the chi-square test statistic without a whole lot of calculator fuss. So we'll go back to the calculator and we'll do that exact same thing. If it's not already there. No, it's not already there. So we'll just do stat test. Then we'll go around to the chi-square test. A, B, calculate. And then it looks like our chi-square test statistic is 6.158. Looking back at the calculator, also the p-value is 0.0131. And the degree of freedom is 1. So that was a really great time saver for us. Also, the calculator can provide us with a picture of the distribution. So we can just draw that as well. Let's go right back to that same menu. It is the chi-square. Oh, I'm in the wrong place, aren't I? We are in stat test, chi-square test, letter C, if you want to just type that in. And this time, instead of doing calculate, we're going to do draw. And it's going to give us all of the same information, except for it's also going to give us the actual shape of the chi-square distribution with 1 degree of freedom. So it does take a little while for this to draw. And then it's also going to shade in the p-value, which is kind of nice. So there we go. It's already shaded in. It's really hard to see, but it's right at the very end there. Now, just a reminder, the calculator in no way absolves you from doing any of the work. I mean, you still have to show the calculation of the chi-square test statistic. You still need to do the hypotheses and the plan. So it just saves you a lot of time. In any case, I hope I'm clear about what you need to show and what you don't need to show. If you follow these StatsMedic guides, then you'll know exactly what you should be writing on your paper. So let's get to the conclusion. Our p-value is definitely less than an alpha of 5%. So our data is going to support the alternative hypothesis. Leave the p-value there and show that it is less than your significance level. And then we're going to get to the alternative hypothesis and we'll substitute that in. And then we'll clean it up grammatically. And that does it for a chi-square test for independence. Now you might be thinking to yourself, wow, that felt a lot like the chi-square test for homogeneity. And you're right. Mechanically, it's exactly the same test. What is different is what we are testing for. Now remember that in the chi-square test for homogeneity, we were testing two samples to see if they have the same distribution of a variable. Here in the chi-square test for independence, we're only taking one sample from one population, and we're checking the two variables from that population to see if they are dependent or independent. And that is the key. In the homogeneity, you have two populations and multiple categories, whereas in the chi-square test for independence, we have one sample, and then we have, one variable and then another variable. So keep that in mind as we do this, as we try to figure out which one's which. I have seen instances where they will ask you straight up, is this homogeneity or is this independence? So you'll have to know the difference between the two. Okay. For each of the following situations, decide whether what type of chi-square test is appropriate. Shopping at secondhand stores is becoming more popular and has even attracted the attention of business schools. A study of customer attitude towards secondhand stores interviewed separate random samples of shoppers at two secondhand stores of the same chain in two different cities. The two-way table breaks down the respondents by gender. Okay, so I noticed that it said we took two samples. We took one sample from store A and another sample from store B. So it looks as though we're trying to compare the gender distribution in store A with the gender distribution in store B. Because we have two samples, we're probably looking at a chi-square test for homogeneity. We're trying to figure out if store A has the same proportion of males and females as store B. That's my reading of this question. Question B. The General Social Survey asked random samples of adults their opinions about whether astrology is very scientific, sort of scientific, or not at all scientific. And here is a two-way table of counts for people in the sample who had 3 levels of higher education. So notice that we took only one sample here, and we're classifying the sample in 2 different ways. So there are 2 different variables here. One variable is the degree being held. The other variable is the opinion about astrology. Okay. So, to me, this looks like a chi-square test of independence. If this was going to be a chi-square test for homogeneity, we would have had one sample for people who have an associate's degree, another sample of people who had bachelor's degree, and then another independent sample of people who had master's degrees. So that would be 3 different samples here that we would have had to use. That's not what's happening. We just have one sample and we're classifying them according to 2 different variables. So the chi-square test for independence seems appropriate here. And then lastly, casinos are required to verify their games operate as advertised. American roulette wheels have 38 slots, 18 red, 18 black, and 2 green. In one casino, managers record the data from a random sample of 200 spins of one of their American roulette wheels. The table displays the data. So let's take a look at this data. We have color, red, black, and green, and then count. Well, this looks like we just have one variable, color, and we're checking the distribution of that one variable in that one sample. That says to me that we are looking at a chi-squared goodness of fit test. So that's it for our look into chi-square distribution. Hopefully you've got all of the mechanics straight. Hopefully you know the difference between the 3 different tests. And of course, good luck on your chapter test, and we'll see you next time. Have a good one.